In Python, have you ever seen syntax like this? In this video, I'm going to explain exactly what this is doing and why this syntax works. But before we understand this piece of syntax, we have to understand that Python provides two types of copies. It provides shallow copies as well as deep copies. A shallow copy will create a new object, but it only copies references to the elements inside the container. Let me try to break that down for you. So there's two cases. Case 1 is when we have non-nested objects, and case 2 is when we have nested objects. The behavior of the shallow copy is different for these two cases. Examples of non-nested objects are primitive data types that are immutable, for example, strings, integers, and floats. An example of nested objects are things like lists of lists, dictionaries, as well as other objects. And we'll see that the two cases here have different behaviors when it comes to shallow copies. So how do we actually create a shallow copy? There's three main ways. First, there's the slice operator. Second, we can use the list method. And third, we can use copy.copy. Let's start with shallow copy for case 1, primitive data types. We start by creating an original list, and this is a simple list composed of 5 integers 1 through 5. Now we create a shallow copy using the slice operator. So we have original list, and we use the slice operator. Now let's modify the first element of the original list and set it to 100. So original list at index 0 will be 100. After that, we're going to print the contents of the original list, as well as the contents of the shallow copy list. Now, what do you expect the output to be? I'm going to click run here and have the Python interpreter do its magic. Is this what you expected? Let's try to understand this. So for case 1 of non-nested objects, these are primitive data types. This slice operator works just like copying the entire list. So original list and shallow copy are completely independent. Changes to the original list does not impact shallow copy. And this is because integers are immutable. But how about case 2, where the elements inside the container are actually nested objects? For this example, let's use a list of lists. We change this simple list to a list of lists. Similar to before, we use the slice operator to get a shallow copy of the original list of lists. And now let's just modify the first element of the first sublist by doing this. Now what do you expect the output of case 2 to be? Is it going to be the same behavior as case 1? Is original list and shallow copy referencing completely independent objects? Let's click run. Now we see that original list and shallow copy appear to be identical. So let me explain. Original list with the slice operator does create a new list, but the inner lists are still shared between the original and the shallow copy. What that means is that references to these inner objects or sublists are shared between original list and shallow copy. So modifying the first element of the first sublist of original list affects shallow copy as well. And this happens because Python doesn't go deeper when copying the inner lists. It only copies references to them. How about deep copies? A deep copy creates a new object and recursively copies all objects inside it, so it doesn't share any references with the original object. Every single element, even if it's a nested object, gets fully copied. So remember that for shallow copying, nested objects get their references copied, so they're not completely independent. But for deep copies, the new object is completely independent of the original. And we create a deep copy using copy.deepCopy. Let's start by importing copy. Now let's create an original list of lists. Original list equals an outer list with 2 sublists. Now let's create a deep copy. We use copy.deepCopy and pass it the original list. Now let's set the first item in the first sublist to 100. Deep copy of 0, 0 equals 100. Now let's print the original list, as well as the deep copy list. And hopefully you're able to predict the output in this case. Let's click run. So what we see here is that copy.deepCopy is creating an entirely new copy of the original list, including all of its nested objects, or nested elements. We see that when we modify deep copy, it doesn't affect the original list. And this is because the two lists are completely independent. We could also change this to original list and click run. And you can see that whenever we modify any of the elements of the nested sublists, the change happens in isolation. So deep copies ensure that all levels of nested objects are duplicated. Let me just convert the deep copy to a shallow copy to show that the behavior is different. Now when we run this, we see that the original list and the shallow copy are both affected. So let's say we have a sequence, and it's equal to some simple list like 1, 2, 3. Python supports single index access, for example, sequence at index 1, and behind the scenes it's actually using the getItemDunder method. This is actually calling sequence.dunderGetItem and passing it 2. But for sequence, we also support slice access. So this is single index access, and now let me show you slice access. So Python's data model supports this kind of syntax where we have sequence, we have a start index, a stop index, as well as a step. And behind the scenes, this is creating a slice object. We have the sequence, we call the dunderGetItem magic method, and we pass it a slice object composed of start, stop, and step. So let's set start to 1, stop to 5, and step to 2. So this slice object will be created with the same parameters. So Python is compatible with the square bracket syntax and will convert this sequence with a slice into this expression behind the scenes. Okay, so why does this matter? What happens when we do something like mylist with the slice operator? What this actually translates to is mylist.dunderGetItem, and it's passing a slice object initialized with none, none, and none. This is because we're not explicitly providing the start, stop, and step. So none for start means beginning of the sequence, so it's equivalent to index 0. And none for stop means go until the end of the sequence. It's equivalent to the length of the sequence. And none for step means take every element, which is equivalent to one step at a time. So what this slice operator does is that it creates a new list, or a tuple, or a string, or any sequence object that includes all elements from the original. And this is because it's initializing a slice object with all arguments set to none and passing this slice object into the dunderGetItem magic method. So it doesn't return a reference to the original list. Instead, it calls mylist.getItem with the slice, and Python returns a new list containing the elements specified by the slice. And remember the general rule of thumb. For simple elements like integers or strings, this copy is completely independent, but for nested objects, like lists inside lists, Python copies only references, not the objects themselves, and that's why it's a shallow copy. All the nested objects are shared between the shallow copy and the original list. If you learned something new today, feel free to leave a like on the video and comment down below. And if you want to stay updated on future live coding videos, you can hit the subscribe button and click on the bell icon to be notified for future updates. As always, thank you very much for watching, and happy coding!